This is Module 4, Lesson 8 homework. This is in the workbook, page 111 and 119 for this particular page. We've got page 120 and page 121, so we're going to do those. First off, number one, a train travels at a constant rate of 45 miles per hour. That's 45 miles per 1 hour. What's the distance d in miles that the train travels in t hours? Okay, so we're going to set us up another one and write us a linear equation here. Okay, constant rate of 45 miles per 1 hour. So 45 miles per 1 hour. And we set up the proportion. That would be d miles in t hours. Okay. So let's go ahead and solve that. That would give us d, the distance is equal to 45 miles per hour times the amount of time, right? In hours. How about if it travels 2.5 hours? Okay, you could set it back up in you could set it up and put it in for time here. Why don't we do that? Why don't we use the linear equation? Distance is equal to 45 times t, and our time is 2.5 hours. Distance then would be equal to 45 times 2.5. And if I do that in your calculator, 45 times 2.5, 45 times 2.5, that would give you 112.5 miles. Okay? Now, water's leaking from a faucet at a constant rate of 1/3 gallon per minute. Okay? 1/3 gallon per minute. 1/3 gallon in 1 minute, right? What's the amount of water W in gallons per minute that's leaked from the faucet after t minutes? Okay, W is gallons, so we put that on the top. And t is our minutes. Okay? If you cross multiply, remember we want our W on the front. We want it to look like y is equal to mx. The one that's on the top is the y. So we want the W in the front. W times 1 is W. 1/3 times t would be 1/3 t. There's our equation. How much water is leaked after 1 hour? Okay, if it's 1 hour, guys, you'd plug it in. W is equal to 1/3 times 1 hour. And W would be equal to 1/3 a gallon, right? If it's leaking 1/3 a gallon in an hour, then that one was pretty straightforward. Look at C. Look at 3. A car can be assembled on an assembly line in 6 hours, okay? 1 car per what? 6 hours. Assume that cars are assembled at a constant rate. How many cars Y can be assembled in T hours? Well, if cars are Y over T, and we know we want this one right here, this top one, to be what we've got in the front. So 6Y is equal to 1 times T. 6Y is equal to T. Divide both sides by 6, and that's Y is equal to T over 6, or 1/6 T. Okay, see? This is actually our slope, our rate of change. That's where it is, right there. Y is equal to 1/6 t, okay? How many cars can be assembled in a week? Okay, we need to know how many hours are in a week. 24 hours in a day, 7 days in a week. 24 times 7. That's 168 hours. And Y is the what? Number of cars. So Y would be equal to 1/6 times our time, 168. 168 times 1 divided by 6 would give me 28. You would get 28 cars in 1 week if you can assemble a car every 6 hours. Okay? Number 4, a copy machine makes copies at a constant rate. The machine can make 80 copies in 2.5 minutes. Write an equation to represent the number of copies N that can be made over T time. Okay, I've got 80 copies per 2.5 minutes, 2.5 minutes. Okay, now we want, let's see, write an equation to represent the number of copies that would be N over T, right? Okay, so we've got 2.5 N is equal to 80T. Divide both sides by 2.5, and you've got the number of copies is equal to 80 over 2.5 times T. Now, what if I got this down to a unit rate? What if I divided 80 by 2.5? That would give me 32 copies per minute. Number of copies would be 80 divided by 2.5 is 32. 32 copies per minute times the number of minutes, okay? Our linear equation, number of copies is equal to 32 copies per minute times the number of minutes. At 0 minutes, how many would I have? Let's plug in 0 for T. Number of copies would be equal to 32 times 0, which is 0. Doesn't that make sense? At 0 times, you got 0 copies. I'm going to put the coordinates here, 0, 0. Okay? I think they actually want us to plot this on the next page. So the number of copies would be 0, 0. At 0 time, you got 0 copies. Okay, let's look at quarter of a minute, 0.25 minutes. The number of copies is 32 copies per minute times 25 hundredths of a minute, or 1/4 of a minute. So I'd multiply 32 times 0.25. 32 times 0.25 would give me 8. I'd have 8 copies after 0.25 minutes. 0.25 minutes, I'd have 8 copies. So let's plot that. Our time on our x-axis, 0.25, that'd be between the 2 and the 5, and I'd have 8 copies. All right. Half a minute. If I get 32 copies per minute and I run it for half a minute, wouldn't that make 16 copies? Let's look and see. 32 times 0.5 would give me 16 copies. So this next point is 0.5 minutes, 16 copies. Let's plot it. 0.5 minutes, okay. 16 copies. Let's go up to 16. There we go. All righty. Let's plot, and that would, let's go back to our next point. Now, 0.75 minutes, 3/4 of a minute. If I get 32 copies per minute, and I multiply that by 3/4 of a minute, 0.75 minutes, 32 times 0.75 would give me 24 copies, okay? So in 3/4 of a minute, 0.75 minutes, I get 24 copies, all right? Let's go over here and let's plot that. 0.75 and 24. 0.75 and 24 would be right here, okay? And then let's do the last point they asked me for. They said in 1 minute, well, we said 32 copies per minute, right? N's equal to 32 copies per minute times 1 minute would give me 32 copies, wouldn't it? Okay, that's the unit rate. It told us that. Okay, so in 1 minute, I get 32 copies. So 1 minute, I would have 32 copies. Let me move that up here some. 1 minute, 32 copies. Okay. Let's see, is this a straight line? I just want to check and see. I'm going to put a line on it. Start there and let's see. Oh yeah, look, we have a linear equation. It forms a line, doesn't it? Okay. The copy machine runs for 20 seconds and then jams. Okay, well, let's think about it. 20 seconds. What fraction of a minute is 20 seconds? That's 20 seconds out of 60. Okay, 20 divided by 60. That gives you 0.3, 0.333, right? It's repeating. About how many copies were made before the jam occurred? Okay, if it occurred at about 0.33, somewhere right in here, huh? About how many copies were made? 10, correct? See, I can go 0.3 on my time, look up here, and then go over here, 10 copies. About 10. If I found about 0.33 on here and saw what coordinate matched it on the y-axis, see, at about 0.33, on the x-axis, what's on the y-axis? 10. That tells me the number of copies that would have been printed in about 0.3 of about 0.33 seconds, right? Let's see. Now, let's look at this one. Connor runs at a constant rate. It takes him 34 minutes to run 4 miles. 34 minutes for 4 miles. Now, there is my rate of change. How about we do a unit rate out of that, okay? How about we divide that 34 divided by 4, and I've got that is the same as 8.5 minutes per 1 mile, right? Now, write a linear equation that represents that he runs like this, okay? T is my time. What else do I have? T is time, M is distance in miles, okay? So M is I've got 8.5 minutes per mile for 1 mile, okay? Time would be, oh, it's miles per minute, isn't it? Miles per minute. Okay, I've got it backwards. We want to do miles per minute. I don't know why I put minutes per mile. We want to do miles per minute. Sorry, let's do this again. Now, let's see. It takes him 34 minutes to run 4 miles. So that's 4 miles per 34 minutes. Okay. Let's see. Write a linear equation that represents the number of miles he can run in any given time interval t. So our miles goes on the top, our time goes on the bottom. We want, whenever we finish this, we're going to cross multiply. We've got 34m equals 4t, right? Let's divide both sides by 34. And I'm back to where I started. M is equal to 4 over 34, our rate, see? Times our time. There's our equation. I want this as a unit rate. I want the bottom to be 1. This is 4 miles per minute. I'm going to divide 4 by 34, and I get 0.12. Let's see, 4 divided by 34, right? 4 divided by 34. We get me 0.12. Okay. Okay, 0.12 times 2. I'm just going to leave it like it. I'm going to leave it like it was. M is equal to 4 over 34 t. At 0 time, guys, if I'm running, if time's 0, how far will I have run? I'll put 4t in for there. Anything times 0 is 0. So my first point is 0, 0, isn't it? At 0 time, I've run 0 distance. 15 minutes, okay? All right. M is equal to 4 over 34 times 15 minutes, okay? Let's do that. 4 times 15 divided by 34. That would be, give me, let's see, 1.8 miles. Okay, so in 15 minutes, we're running 4 miles in 34 minutes. We do 1.8 in 15. That makes sense. Okay, now 30 minutes. It's going to be close to 4 miles, right? M is equal to 4 miles in 34 minutes. Let's multiply that by 30 minutes. So it's not going to be quite 4 miles. 4 times 30. And you divide that by 34. And you get 3.5. So see, almost 4 miles, 3.5. Okay, so 15 minutes, it was 1.8. Let's do that. 15 minutes was 1.8. 30 minutes was what? 30 minutes is 3.5. 30 minutes is 3.5. That's halfway between 3 and 4. Then I think I got 2 more to do. If I run if they go 4 miles in 34 minutes, and we want to know how far they go in 45, we multiply that by 45. 4 times 45 divided by 34 would give me 5.3 miles. So in 45 minutes, they'd run about 5.3 miles. 35, 45, 5.3. 45, 5.3 miles. Okay? And then the last one. In 4 miles in 34 minutes, and you run for 60 minutes, it's going to be less than 8 miles, because that would be 68 minutes for 8 miles. Okay? So let's say 4 times 60. And then let's divide that by 34. And I've got 7.1 miles. Okay? So at 60 minutes, we got 7.1. 60 would be 7.1. Is this a linear equation? Can I put a line through it? Let's look and see. Yep. Again, a linear relationship. Okay? And let's see. Connor ran for 40 minutes before tripping and spraining his ankle. About how many miles did he run before he had to stop? Well, look, we can look at our chart. 40 minutes, okay? At 40 minutes, he had run somewhere between 4 and 5 miles, maybe about 4.5 miles, right? About 4.5. Okay, I looked it up on the chart. And that covers the homework.